Let's find the inverse of 3 big bad mamma jamma problems, and here's the first one. H of x equals the 7th root of x plus 1 and then minus 4. So if we were going to find out what the inverse of this is, then step 1, we would switch x and y. This is y, so it becomes x. This is x, so it becomes y. And now we're going to solve. So when we solve, we need to, well, solve. So what do we do first, right? Are we going to raise it to the 7th first? Are we going to subtract 1? Are we going to add 4? Are we going to put this 1 and this negative 4 together? Like, well, first of all, no, that's just wrong. This one's under a root. This one's being radicalized right now. And that one is not in that root, the 7th root. So we are going to, and you've seen this, but what we're going to do is reverse the order of operations. If I asked you to simplify something, you would do, check this out, parentheses first, exponents, multiplication and division, then addition and subtraction. And you learned that way back in the day, PEMDAS. So parentheses are grouping symbols, then exponents, which also includes roots, by the way, and then multiplication and division, whoops, from left to right, and then addition and subtraction. So if you're going to solve, not simplify, then you're undoing this process. Inverses are undoing. So let's make it big and green and bold and highlighted. We're going to reverse this. We're going to do it backwards. So subtraction and addition. Also, you could say addition and subtraction because the order there is kind of arbitrary in a sense. Division and multiplication, and then exponents and grouping symbols, your parentheses. So when we solve for a variable, that's the order we're going to do it in. And so let's erase this and solve for y right here. So this is the process I'm going to use. I'm going to look for subtraction and addition first, and I see some subtraction and addition that could happen. Again, you can't get into this. This is grouped, okay? That's a grouping symbol. It's under that radical, so you can't get in there. That's your parentheses, your grouping, it's last. So subtraction and addition needs to come first. We're going to add 4 first, and that brings the 4 over, and now we still have the 7th root of y plus 1. Every time I do this, I kind of reset. I start back over. So then I look again and I say, is there any more subtraction or addition? Well, no, I would have done it already. Well, now, that's frustrating. Is there any division or multiplication I can do? No, there's not. So are there any exponents I can take care of? And yes, there is. There is an exponent of, well, 1/7, okay? A 7th root is the same thing as an exponent of 1/7. I'm not going to write it that way right now, but if you wanted to, you could. Switch colors just to show what's about to happen. We're going to raise this side to the 7th power and this entire side to the 7th power. Please do not try to expand that and make x plus 4, 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 and then put all that together. Not worth your trouble. Doable, lots of fun. Pascal's triangle can help you with that if you really want to get nerdy about it, but that's not the purpose of this lesson. Leave it exactly the way it is, perfectly fine. You have now broken into this radical. That takes care of your exponent. Start all over. Is there any subtraction, any subtraction or addition that you see? Yeah, me too. Let's subtract 1. So once we subtract 1, we'll have x plus 4, all to the 7th, and then minus 1. Don't try to put that 4 and that 1 together. Nope, nope, nope. And then that's equal to y. We have now isolated y, but the purpose of this was to find an inverse, so there's your inverse. Okay, so this whole SADMAP thing, it's going to go with us as we go. So parentheses, exponents, multiply, divide, addition, and subtraction, or reverse it. Years ago, I had a student, I was teaching this, and he wanted to find a way to remember it, and so he made up this thing, and it was the most random thing ever. I'll tell you in a minute. You know, there's like, please excuse my dear Aunt Sally. Well, his was not that. So parentheses, exponents, multiply, divide, addition, subtraction, and the SA and the DM are grouped together. Okay, again, I'll tell you what he said in a minute. It always stuck with me. When he first said it, I thought, I'll never remember that. It's been over 20 years. I remember that. Okay, let's start with subtraction and addition. Do you see subtraction and addition that can be taken care of? And yes, the answer is let's take care of that. Actually, the answer is wait. Let's write this better. Don't let that exponent that's a fraction scare you. We'll deal with it when it comes, okay? But we're not there yet. That would be an exponent. He's down here. Okay, we're going to subtract 1. Y to the 3 halves minus 6, and that's over 7. Okay, we have now moved to the 1. Every time we do this, we start all over. Okay, we did that. Now, any subtraction or addition? No, we've done it. Any multiplication or division? Yeah, actually. This entire mess, this numerator, that you could say is grouped together, grouping symbols, that would be parentheses. That entire mess is divided by 7, so we can undo division with multiplication. So we can multiply both sides by 7, the entire side. So this is not 7x minus 1. This is 7 quantity x minus 1. You can distribute if you want. I actually will not. I will. 3 halves, that's a song. There we go. All right, we have just taken care of subtraction and addition and division and multiplication. Start all over. Subtraction and addition, do you see any? Yeah, I do too. Me too. I see it. I can take care of it. Let's add 6. So I'm not going to show all the work, but basically you have y to the 3 halves. And that is equal to, well, you're going to add 6 to negative 7. So 7x and then minus 1, because you added 6 to it. That 1 gets a little bit long, but whatever. Here. Fixed. You'd never know. All right, now we have to deal with an exponent. And so, I wonder if he's ever going to tell us how to memorize this. Order of operations backwards. I'll tell you in a minute, for real. So, exponent. How do I undo an exponent? So let me show you something cool. Just kind of side note and switch colors here for a second. If I gave you x squared, no, let's do it this way. If I told you that x equals y squared, and I asked you to find the inverse of that, you would take a square root, right? You'd be like, oh, let's square root this guy. And so you'd get this, right? Okay, I mean, there's domain restrictions and stuff, but in the purest form, that's what you'd get. Let's do this differently. The square root and the squared can cancel each other out in the same way, different problem, that a cube root and an exponent of 3 can cancel each other out. Just writing the same idea with different exponents because of this. If I had, let's do this one again. If I had x equals y squared, you don't have to write all this like I said, and I wanted to raise it to the 1/2. Whoa, where'd that come from? Okay, an exponent of 1/2 is a square root. Whether anybody told you or not, an exponent of 1/2 is a square root. So I am going to raise this to the 1/2 power. And here's how that works. If I wanted to, like over here, cancel out a square root and a squared, they just cancel out. But in this case, a power to a power, they multiply together. Okay, side note to my side note. If I handed you x to the 5 all squared, you'd say it was x to the 10 because 2 times 5 is 10, okay? 2 times 1/2 is 1. That's what you were aiming for. You were aiming for y to the 1, so then you'd have this. Let me say all that summed up like this. You're going to raise this thing, to the reciprocal power, because when you multiply them, they'll cancel out and give you a 1. Because 2 times 1/2 is 1. So all that was a side note just to say that in dealing with this exponent, the very best thing that you can do is raise this thing to the 2/3. And raise this whole thing, entire thing, to the 2/3. And don't simplify this side. Don't. I'm going to show you how it can be rearranged, but we're not going to play that game in terms of like trying to simplify any further because it won't be on that. Okay, so y equals this. That is y. That is also our inverse. And that gives me 7x minus 1, and that is to the 2/3. And this is correct, but I also want to show you how it could be written. And we could have rewritten this exponent in the same way. The denominator of a rational exponent, okay, denominator, bottom of a fraction, of a rational is a fraction, exponent is the root you're taking. Okay, back up here for a second. This problem was this problem. So when I square rooted, I had it to the 1/2. A square root is an exponent of 1/2. A cube root would be an exponent of 1/3. Okay? What about that 2? Square that whole thing. Okay, now we can argue over where the squared goes. It could go inside, squared around the whole thing. Could go outside squaring the entire operation. Either way, it's correct. And we have found the inverse. So, big idea. It wasn't difficult till we got to here. Raise it to the reciprocal power. This 3 cancels with that 3, that 2 with that 2 gives you y to the 1, which is the inverse. And then it gave you that on this side. So, years ago, a student said, I don't know how I remember this. Soupy aardvark dingo melon exit paper. You waited all that time just for that, right? Soupy aardvark dingo melon, I think it was possessive, dingo melon's exit paper. So the dingo melon had an exit paper. Why? I don't know. Okay, let's go to slide number 9 on my screen, which has lots of 9s in it. We're going to find the inverse of this guy right here. Switch x and y. Solve for y. Soupy aardvark dingo melon's exit paper. Okay, subtraction and addition come first, division and multiplication come next, exponents then parentheses, grouping. Okay, any subtraction or addition? Yeah. Can I get to it? No, it's in a grouping symbol, so I can't. Well, that's disappointing. Okay, any division or multiplication? Yeah. Can I get to it? No, it's in a grouping symbol. Okay, any exponent? Yeah. How do I undo an exponent of 9? Well, okay, we could do the same trick we just did and raise it to the 1/9 power. Don't be looking there because that's kind of, I'm just overusing the 9 here. I could raise this to the 1/9, write this if you want to, or you could throw your pen like I just did. You could call it to the 1/9 power, that's fine. I'm going to call it a 9th root instead. Okay, so we're going to take, let's switch to green. I'm going to take a 9th root of this entire side. That's going to cancel a 9th root with the 9th power and the 9th root of this side. And that gives me, next step, the 9th root of x equal to, okay, everything that's left over, which is 9y to the 1/9 minus 9. Okay, lots of 9s. Start all over. Soupy aardvark. Subtraction and addition. I see it, you see it, we both see it. Let's do it. Let's add this 9 to the other side. So the 9th root of x gets this 9 added to it. Now, it doesn't go under the radical. It wasn't part of that process. There we go. Okay. Do you see any more subtraction or addition? No. Division, multiplication? Yes. Let's divide by 9. So if you want to switch colors and show the process, you could divide by 9, divide by 9. And that gives me some cancellation over there. And so I have y to the 1/9, we'll take care of that in a minute, equals the 9th root of x plus 9 over 9. Now, if you're thinking what I'm thinking, then you're thinking that 9 divided by 9 is 1, and you are correct, okay? 9 divided by 9 is 1, but I don't want to just start canceling those because that would be wrong. All right, let's digress for a second. Don't feel like you have to write this because I'm going to erase it. But I could simplify this a little more and treat it like 9th root of x over 9 plus 9 over 9, which would give me 9th root of x over 9 plus 1, which is equal to all this stuff that I just didn't write over and over. Okay, that was a whole lot, but basically, if you're looking at this and saying 9 over 9 is 1, yes, but be careful because you'd have to divide this term by 9 as well. I personally find it best not to even mess with that. That's just my opinion. I don't get paid for my opinions, I get paid for my math, so let's proceed with where we were, and we'll leave it like that. So what I am going to do is switch to a green, and then I'm going to take care of my exit paper, and that means I'm going to take care of my exponent, not my paper. What I'm going to do is raise this to the 9th power. This is the 9th root. To undo a 9th root, you'd raise it to the 9th power. So we're going to raise this entire side to the 9th power. And that's going to give me y, which is the inverse of g. Once you have y all by itself, don't feel like you have to write y. We found the inverse. So g inverse, there it is 9th root of x plus 9, all over 9, all to the 9th power, and we're done.